Hello all, welcome to MES e-learning channel. In this video, we are going to see a problem on concurrent force system. So this is a given problem. The problem states that the resultant of the three pulls applied through the three chains attached to a bracket is theta as shown in the figure. So on the right hand side you can see, so we have three pulls and all the three pulls are like attached to a bracket with the help of the theta. So we have to find out the magnitude and angle theta of the resultant. So we have to find out this resultant and we have to find out the theta for this resultant as well on the right hand side. So you may be wondering, this image looks complicated, but you can simplify this image. So solution. So to find out the resultants, we need summation of fx and we have to find out summation of fy, and we know the formula r equal to root of fx square plus summation of fy square. And to find out the theta will be equal to tan inverse of summation of fy divided by summation of fx. So these are the terms we are going to use to solve this problem. So first of all, let's try to simplify this diagram. So we can see that, so this is the point of origin. So we can draw the earth quadrant and we have a vertical force. A vertical force of 800 Newton, and we have an inclined force of 240 Newton, and this is making an angle 50 degree with the horizontal x-axis, and we have a downward force as well, it is 380 degree Newton. So we have to find out the resultant of this r, what will be the r and what will be the theta. Okay. So now we are going to take the frame the equation of summation of f of x, which is all the horizontal force. So this will be equal to, there is no horizontal force, but we have the inclined force, that is 240. So we have to resolve this inclined force, 240 Newton, which is a inclined force. Now to resolve this, we will get two components of that inclined force, that is, since this is making an angle with horizontal axis 50 degree, so this can be 240 cos 50 and this vertical component will be 240 sin 50. So if you see the diagram, we have only one horizontal component, that is 240 cos 50. So write it down. So and this is moving from left to right. So if it is moving left to right, it will take it as a positive value. So 240 cos 50. So if I want to calculate this 240 cos 50, I will get the value as 154.269 Newton. So we found out one component, that is summation of f of x, and similarly we are going to find out for summation of f of y. Now summation of f of y is nothing but all the vertical forces. So in the diagram you can see we have one vertical force, that is 800 Newton, which is acting upward. So if it is upward, we have to take the positive value, that is plus 800, and we have one more value, that is 380, which is acting downward, that is minus 380 Newton, and we have one more force which is acting 240 from the inclined force which is acting upward, that is positive 240 sin 50. So apart from these forces, we don't have any other forces. Now we have to calculate this value. If we calculate this value, so 800 minus 380 plus 240 sin 50 will get the value as 603.85 Newton. So this is summation of f of y. So now to find out the resultant, We know the formula, resultant R equal to root of summation of f of x square plus summation of f of y square. So final we have root of 154.269 square plus 603.85 square. If you do the square, so we will get the value as 154.269 the whole square, the root of this thing. We will get as value as R will be equal to 623.24 Newton. So this is the resultant. Now if you want to find out the theta as well, so angle theta will be equal to tan inverse of summation of f of y divided by summation of f of x. This will be equal to tan inverse of f of y is 603.85 divided by 154.269. 603.85 divided by 154.269. We get the value as theta equal to 75.66 degree. So for the given system, the resultant is 623.24 Newton and the theta is 75.66. So this is the final answer for this particular sum. Thank you guys.